Hello, Highland Math Team. I have 5 problems for you this morning, and I want to work them out. Hopefully this will help you get ready for our contest, number 2 contest that's coming up. Okay, here we go. Compute the following. 2 times 12 plus 5 times 48 plus 4 times 24. Now, usually in these types of problems, there's a pattern or a trick that we try and figure out. And the first thing I noticed about this is that all of these multiplication problems are a number multiplied by a multiple of 12. So if I think about it in those terms, this is 2 times 12. And this is 5 times 4 times 12, because 48 is 4 times 12. And this is 4 times 2 times 12, because 24 is 2 12s. So we just have a bunch of 12s here. We have 2 12s from this one, and we have 5 times 4, that's 20 12s. And we have 4 times 2, that's 8 12s. And so how many 12s do we have? Well, each of these are like packages of 12s. How many packages or groups of 12 do we have? Well, 20 plus 8 plus 2 is 30. We have 30 12s, and that becomes a much easier multiplication problem than doing all of this. That is going to equal 30 times 10 plus 30 times 2, which is 360, and that's my answer. You could do it without looking for a pattern. You could just do 2 times 12 is 24 plus 5 times 48. You could figure out those and then add them up. But I like this way because it helps us find a pattern and it gets us to the same answer. You could check it this long way too if you wanted to. Do it 2 different ways and then check it. And you would get, if you got to the same answer, you would be pretty confident that you got the right computation. Okay, how many digits are in the product of the following? So we know a product is an answer to a multiplication problem, and it's asking how many digits. So it doesn't even need the answer. And in fact, we put the answer, it would be wrong because it wants to know how many digits are in the product. Okay, this is another one where we're looking for a pattern. The first thing I notice is that it's 2 times 3 times 5 and 2 times 3 times 5 times 2 times 3 times 5. So it's repeating. So I thought of 2 different ways to do this. One is to say, well, 2 times 3 is 6 times 5 is 30. So this is 30 times 30 times 30. Okay? That's one way to think about it. The other way I thought about it is if you have 2 times 3 times 5 times 2 times 3 times 5 times 2 times 3 times 5, we have some groups of 10s. Because 2 times 5 is 10, 2 times 5 is 10, and 2 times 5 is 10. So it's 10 times 3 times 10 times 3 times 10 times 3. Okay? So either way you think about it, I kind of like the second way because I can immediately see that 3 times 3 times 3 is 3 times 3 is 9 times 3 is 27. And then if I times that times 3 tens, well, anytime we multiply by 10, we just add a 0. So that equals 1,000 because it has 10 times 10 times 10. That's 3 zeros we need to add. 3 zeros is 1,000, and we get 27,000 for our final answer. 30 times 30 times 30, if you knew the cube of 3 to the 3rd power equals 3 times 3 times 3 equals 27. You could think, well, 30 times 30 times 30 is going to equal 27,000. Okay, adding those 3 zeros. Okay, both times you come up with the same answer, 27,000. But the question asks, how many digits are in the product of the following? So the digits 1, 2, 3, 4, 5. The answer would be 5 digits. Okay, next one. I love these kinds. Okay, Lisa has a secret 3-digit number. No digit is 0. Okay, so I'm looking for a 3-digit number. 1, 2, 3 digits. So we're going to have a hundreds place, a tens place, and a ones place. Okay, here are the clues. the hundredths digit is a multiple of 4. So here's my hundredths digit. It's a multiple of 4. Now we're only dealing with the numbers 1 through 9 because no digit is 0. So in the numbers 1 through 9, which ones are multiples of 4? Well, there are just 2 of them, 4 and 8. So this one could be 4 and 8. The tens digit is a perfect square. Okay, a perfect square just means that it's a number that equals some other number times itself. So 1 times 1 equals 1, so 1 is a perfect square. 2 times 2 equals 4, so 4 is a perfect square. 3 times 3 equals 9, so 9 is a perfect square, and it could go on and on. But as far as the digits from 1 to 9, 1, 4, and 9 are all perfect squares. Okay, so that's the tens digit. The ones digit is a multiple of 3. Well, what are the digits that are multiples of 3? 3, 6, and 9. Okay, we need one more clue. The digits are in decreasing order. So starting on the left, because we read left to right, the digits are in decreasing order. So if something's decreasing, it's starting from big and getting smaller. So I'm going to start with my biggest digit here. It's going to be 800. Which of these is smaller than 8? Well, 4 and 1 are smaller than 8, but I know it can't be 1 because I still need this one to be even smaller. So I know it's going to be 4. And then the only digit left here that is smaller than 4 is 3. So her secret number is 843. Now, if you're doing this on a contest, I'd encourage you to go back through the clues and make sure that your number that you came up with meets all the criteria. And it does. 843 is Lisa's secret number. Okay, 2 more. How many four-sided figures can be traced using only the lines in the picture? Okay, so they have to be four-sided figures. Whenever there's a problem like this, you need to make sure you do it in a systematic way so that you don't count things twice and you don't miss anything. So I like to label. I'm going to call these points A, B, C, D, E, F. So I can organize the figures that I find and make sure I don't count something twice. Okay, so let's think about it this way. Let's think of the ones that include A. So if I did A, B, D, E, that would be a four-sided figure, A, B, D, E. I could also do A, C, D, E. A, C, D, E. C, D, E. What else could I do? How about A, B, D, F? A, B, D, F. That would work. A, B, D, F. And is that all for A? Yep, I think I got 3 that include the A. Okay? Let's think of ones that don't include the A. Let's start with B. Well, I could go B, C, D, E, B, C, D, E, or B, D, F, E, B, D, F, E. What else could work? What about, I already did this one. What about, let's see, I have B, C, D, E, B, C, F, E. Did I do that? No. B, C, F, E. Going all the way at the top, then going down here. Okay, are there any triangles, or excuse me, are there any four-sided figures that I could use without A or without B? I don't think so, because there's no way I can use these 4 points to make a four-sided figure. C, D, F, and E. It has to use either A or B. And that's my answer. How many four-sided figures can be traced using only the lines? 1, 2, 3, 4, 5, 6. The answer is 6. Another way to think about this is just to think that 2 triangles make a four-sided figure. So I could label, instead of labeling the points, I could label the triangles. Say this is triangle A, triangle B, triangle C, and triangle D. So A and B together make a four-sided figure, and B and C together make a four-sided figure. B and D together make a four-sided figure. And I think those are all the ones of sets of two. Okay, well, what if I combined three triangles? That would still make a four-sided figure, A, B, and D, for example. A, B, and D makes a four-sided figure. And A, B, and C makes a four-sided figure. And C, B, and D, CBD, these three together makes a four-sided figure. And so that's another way to think about it. I think both ways would work as long as you organize your figures so that they're in a way that that you don't repeat different triangles. Okay, and I probably could have done this even more organized by doing the BC than the BC ones, you know, doing it in alphabetical order. But whatever works for you to be able to make sure you're not overlapping, that you're doing it in an organized way. Okay, final question. The perimeter of rectangle ABCD is 36 centimeters. So this is a perimeter. Perimeter means the fence around the edges around the figure. Side AD right here is folded up and shown as shown so that D lies on the midpoint of AB and AE in the crease. So this is the middle, they're telling us. So this AD is equal to DB. What is the area of figure ABCD? So we're looking for the area for our answer. We're given the perimeter, we're looking for the area of this new figure. Okay, perimeter is 36. Okay, so we know that AD is equal to half of AB. So let's just call this P for perimeter. This side is the same as half of this. And that would be the same as this. Does it make sense? So since we're folding this up here, this equals half of AB. So this P is equal to P here. This, of course, is equal. All of these are equal. We've gotten in equal little portions here. So there are 6 portions of the perimeter that equal 36 centimeters. Well, that means that each one of them is equal to 6. Each one of these little sections is equal to 6. So if we try and figure out the area of this, we know that this side is 6, this side is 6, this is 6, this is 6. And that will help us find the area. This square is going to be length times width, 6 times 6, 36 centimeters squared. Now, how do we figure out this one? Well, if we had a square here, this square would be 36 centimeters squared, but we have the triangle part. We have half of it. The area of a triangle is just half of the length times the width. So half of the area of the rectangle that the triangle is half of, okay? So this would be 36 times half, 18 centimeters squared. So this part is 18, this part's 36. So you simply add them together and we get 54 centimeters squared. And that is the answer. That's the area of figure ABCD. Thanks so much for watching. I'll see you guys on Monday. Bye.